Okay, activity 3, making connections. So this is just to summarize some of the content from this area. So in it, we talked about slope. What is this exactly? So we've been doing rate of change, and now we're calling it slope. So basically, it's just how steep a line is. So like, let's say we wanted a line to have a slope of 2. And we're gonna draw it anywhere on this graph. Like, let's just say it had a y-intercept of 0. We'll just start it there. We wanted this line to have a slope of 2. So it'll have like maybe a rise of 2 and a run of 1. So it'll look like this. Oh, that's rough. Sorry. Okay, my grid lines are pretty brutal here, but well, let's say that's my line. I'm going to need to get better at using this because I feel like there's probably a line tool and I can't locate it. Oh, let's explain everything. Wait, I'm going to push all these buttons until I find one. Are you enjoying this video? Comment below. I think I turned off comments. Okay, so we're just going to freehand that guy until I figure it out. So there's our line with a slope of 2. Let's say we want to make a line that has a slope of 1. Do you think our line's going to be, like, how will that look different? It's going to be less steep. So now it's going like up 1, over 1. It's going to be like that. Look at that. Our line's not as steep. Let's draw that. Okay, let's say we had a slope of, oh man. Okay. There we go. So now let's try a slope of, in a different color. Just comparing stuff. Let's try a slope of 4. So I'm starting everything at the origin for now. So I'll go up 4, 1, 2, 3, 4, over 1. Up 4, over 1. So now my slope's even steeper. So this is just to kind of show you like different slopes. Putting them all on one graph so we can just see the slope of 4 is the steepest line, and then 2 is less steep, and 1 is even less steep. So that's what slopes are like. What do you think a slope of 0 would look like? If you guessed a horizontal line, you would be right. So if you had a slope of 0, it's like you're going up nothing and over 1. Up nothing, over 1. So that's going to be just a horizontal line. No steepness at all. It's totally flat. Okay. Let's talk negative slopes too. How are they different? So negative slopes, just like back in our other unit. That's fine. Just like back in our other unit with the negative correlation, it's kind of like the same thing. Our negative slopes go down to the right. So let's say we had a slope of -2. It's gonna be the same like incline, steepness as a slope of 2, but it's gonna be heading in the other direction. So if we went up 2, then we could go to the right one, up to right one, or we could go like down to, or sorry, down to, I'm saying right, but I'm actually going left. Oh my gosh, worst video of all time. Okay, so up to left one, that's what I was doing. Anyways, whatever, it doesn't matter as long as your line is sloping down to the right. So that's what this one's doing. You know, I should have made that the same color as the positive one, which was red, just so you could see it. So that's our slope of -2. So same steepness, is just going in the other direction. So to summarize, negative slopes are sloping down to the right, and positive slopes are going up to the right. Okay, so there you go. That's what slope is. And basically, I was just using the technique where, since these were all just whole numbers, I was just putting them over 1 to make them a fraction, and then I could tell what my rise and my run are. Okay, let's move on. Oops. Oh dear. Okay, so we talked about horizontal lines. So just really quickly, horizontal lines we said had a slope of 0 because they basically don't have a rise; they just have a run. So if you thought about that in terms of your fraction, like we're not going up at all, but we're going over, who cares how much? Like 1, a billion, doesn't matter. It's going to be a flat line. And then our vertical lines over here if you want to have a vertical line, looks like your rise is going to have a number. So like, you know, say my rise was 3, but my run is 0. Like I'm not going over at all, left or right. I'm just going up 3, over none. So because we can't divide by 0, we say the slope of a vertical line is undefined. Oops. Okay. Sorry, can't scroll down here. Then let's just quickly talk about Y-intercept. So another part of this unit was just talking about the Y-intercept, and that's just where your line crosses the Y-axis. So you have an X-axis and a Y-axis, and we use the Y-axis in our equation of our lines, our slope-intercept equations. So the Y-intercept's just, yeah, where the line crosses. So like, say I plotted a point at 2 here on the Y-axis, and then I graphed a line of whatever slope. I can see that my Y-intercept is 2. It also has an X-intercept, like right here, but we just aren't using that right now. We're just talking about slope-intercept form, which is just using the slope and the Y-intercept for our straight lines. So I was just trying to explain, yeah, the Y-intercept is just where the line crosses the Y-axis, like so. So this Y-intercept would be 1, 2, 3, 4, 5, -5. Okay, hopefully that makes sense. It's not too hard. Okay, so for equations of lines, just to sum up what we've been doing, we've been just working on our slope and Y-intercept practice. So, and we've been working on our slope-intercept form of equations. So y equals mx plus b. And just being able to identify which one's the slope, which one's the Y-intercept, and identify it on a graph. And so here's a bunch of equations. So all we have to do is identify which one's the slope and which one's the Y-intercept. And they're all in slope-intercept form. It's pretty easy. So just this guy right here in front of the x, that's our slope. And this guy right here, this constant on its own, this 2, is the Y-intercept. So we have a slope of 3 and a Y-intercept of 2. Here we have a slope of -2, and we have a Y-intercept of -5. So you gotta pay attention to the sign that's in front of the number also. This one, it looks like we don't even have a Y-intercept. We just have a slope of 4. This guy, what? We don't even have a slope. So what do you think our slope would be? I'm gonna say 0. Slope's nothing, or it's 0. So it's like 0x, then you didn't, you know, we don't have to write that. And that's our Y-intercept. And then this one right here, this guy, since there's always like a 1 in front of the x, we don't write it. This guy would have a slope of 1 and a Y-intercept of -1. Okay, so that's kind of how you identify slope and Y-intercept from slope-intercept form. And then finally, to wrap this up, the last part of this unit talked about real life situations. So it was a bowling situation. Say you're gonna go bowling and you gotta pay for shoes that are $3, and then you're gonna bowl a few games. So you're gonna pay $6 per game. So if we wanna make a table of values, I don't even know exactly what the graph was on there, but let's say I wanted to graph, you know, number of games versus cost. So if I play no games, 1 game, 2 games, 3 games, 4 games, what kind of price am I looking at here from a bowling party? Okay, so I got a shoe rental of $3 that I got to factor in, and it's going to charge me $6 for each game that I bowl. Okay, so if I play no games, I guess I'll have to pay for my shoe rental, so that's $3. If I play 1 game of bowling, that's $6, but then I also have to pay for my shoes, so that's $9 altogether. If I bowl 2 games, since it's $6 per game, that's $12 for my bowling game, plus my $3 shoe rental, which I think is $15. If I play 3 games of bowling, 6 times 3 would be $18, plus my shoe rental, so $21. And finally, if I play 4 games, 4 times $6 per game is $24, plus my $3 shoe rental is $27. So that's how you fill out a table of values. And we could find our first differences from our table of values if we want to, because we were doing that in an earlier unit, just to see if things were linear or not linear. And our table of values looks like it's going up by 6 every time. And if we wanted to draw a graph of that, you would just make a set of axes here, and then I would put cost not there. Haha. Sorry. I'd put number of games down here. And then I'll put cost on my y-axis because it's going to depend on the number of games I play. It's the dependent variable. I'll start at 0 games, and then I'll just go up by 1, 2, 3, 4. Okay, sorry, I just got interrupted, so I'm sorry if I've missed a spot here, but, okay, so we're going up by 1s on the bottom here, and then for cost, I see that I have to get all the way to 27, so maybe I'll go up by, 3, 6, 9, 12, 15, I don't know. Okay, I'm going to do it anyways. So I'm going to skip every other line. So I'm going to go by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27. I'm sorry this is a bit of a rough sketch here. Okay, so then you're going to plot your points from your table. So number of games, 0, costs you $3. Number of games, 1, costs you $9. 2 games costs you $15. 3 games is $21. And 4 games is $27. Okay, mine's a bit off here, but anyways. And then, there you go. Okay, so then we made our graph, and we know our, oops, okay, sorry. So let's just go back to some stuff. So we know our first differences over here are all 6, which that told us that it would make a straight line, because since our first differences are all the same. And it turns out that the slope of this line is also 6, because if you look at the games, they're increasing by 1 every time. So remember how we talked about first differences kind of like your rise, and the x values here is kind of like your run. So yeah, it turns out that does make sense, because if we go over 1, then we go up 6. Like if you're using my scale here. So from 3 to 9, that's 6. And from 0 to 1, that's 1. So we have a slope of 6 for this graph, which is the same as our first differences. So the slope of our line is going to be 6, which makes sense, because the slope, or the rate of change, it's changing by $6 every time, because like that's the cost of each bowling game. So every time you play a new game, you have to pay an extra $6. Whereas your constant in this example is your shoe rental. So your Y-intercept is the cost of your shoes, $3. So that's kind of like your initial value. So this is a partial variation kind of situation. So if we wanted to write what do you call it? Equation. Then we would just use the format y equals mx plus b. So y equals 6x plus 3 could be the equation of this bowling game. And if you didn't want to use y's and x's, you wanted to make it more, I don't know, matching to this situation, then maybe I would say like my y is cost, so maybe I'll say c instead, equals 6, and instead of x, maybe I'll do a g for number of games, or sometimes people do like n's for number, I guess. Maybe I'll do an n plus 3. So I can make it more, instead of x's and y's, it'd be kind of cooler to let c represent the cost and let n represent the number of games. Cool, so that's how we make a graph, table of values, and an equation from kind of like a real life situation. Yeah, I think that basically sums up most of the stuff for this unit, or this activity. Hope that helps. Sorry about the not well-planned video.